We are finally getting to the very important topic, because functions coding or tools are really the foundations to create some simple agents. It will give the ability for your LLM to perform some actions outside of their sandbox, to get access to up-to-date knowledge, get access to your own data, and really perform some actions for you, such as creating documents, sending emails, and much more. And you will see that the process is not very complicated. We just need to take it step by step. In a nutshell, the first step is that you will expose the tools to your LLM. So you will give them the description of the tools, so they know what are the different tools which are available and in which situation they should use them. And when they want to use these tools, they will respond to you with a so-called tool call. So they will tell you the name of the function that they want to run, as well as the arguments that they should plug in this function. And then it's up to you to execute these functions and to return the result to the LLM. But if you run everything in the loop, of course, you will not need to execute these tools manually. This will be automated. But this is in essence how the process is working. So let's get started. As usual, we will just create a client. This is very simple. You are used to it now. And to keep the process extremely simple, I created two Python functions, one that can just sum up two numbers together, and another one that can just multiply these two integers together. So let's execute it. And so far, these are pure Python functions. So if you try here, you can easily just run them. I want to add 5 and 7, for example. And you are getting the result here, 12. So nothing which is really agent specific so far, pure Python code. After that, this is the important step. We need to document these functions, so they really become tools for the LLM. And here I created a list which is called toolbox, and inside I've got two dictionaries, one for each of my functions. So there is the first one here, and there is the second one here, and they've got exactly the same format. And this is not a format which is specific to Mistral here. This is the same as you will find, for example, in the OpenAI SDK, because this is the company that really came up with this format at the very beginning. And some parts of this documentation is fixed. For example, the type, it's a function. Then you need a dictionary within the function key. And if you follow along, you will see that it's not very complicated to populate those. So you need to populate here the name of your function. The description is the very important part. This is some kind of a prompt engineering once again, because you need to describe to the LLM what is the function about, what it can perform, and in which case it is supposed to use it. In that case, this is a very simple function, so it does not need very extensive documentation, but in some cases, if you realize, for example, that your LLM does not call the right function at the right time, it may be because the description is not good enough. Here, it's just to return the sum of two integers. And after that, you need to document also the parameters of your function. In our case, we just have x and y, that are two numbers. So here you see that I added x, here y. Both I need to specify the type, these are numbers, and the description. This is just the first number I want to sum up, and then the second number I want to sum up. And both of these arguments are required. This is also what we mentioned here. So the LLM can understand if it is obliged to provide these parameters in every tool call, or if some of them may be optional. And then I did exactly the same, but this time for the second function, multiplier. So slightly different description. This time we don't return the sum, but we return the product. Apart from that, this is fairly the same description. So let's execute this. And I will start managing my memory. So I create a list. Looks like I didn't import the system message class. So let's do it here. Still in the models module, import system message. And here also I explain the persona for the LLM, your helpful assistant, and I also mention that it is a good idea to use tools to respond reliably to the questions. So here you give a little bit of push to force the LLM also to use them. But there are some other parameters that you can use to achieve this. It's up to you to try different approaches and to see which one works best. Because when you see then my prompt, I'm just asking to add 3 and 76. This is something which is not very complicated. These are not large numbers, and it's very possible that the LLM will be able to answer to this question without using a tool. But we want to make sure that it does so. Here we are asking two things. First, to do the sum of these two numbers, and after it receives this result, to multiply it by 3. Like this, we will see if it can break down the task into several steps, and also if it is able to use the two functions, the one to sum up the numbers and the one to multiply. Then we can request the completion. So as usual, we provide the model name, and I'm still using Mistral small because it's good with this function calling. The messages are contained in my memory list. And additionally to what we have seen so far, you need this time to provide the tools. So you see that here, the tools parameter, you provide the list of all these descriptions that you wrote in the previous steps. So toolbox, this is this list of dictionaries that you need to provide. So you see that at this point, the LLM itself does not have access to your function, only to the descriptions of the functions. So here we added this toolbox. Tool choice, this is optional, and you can choose between auto, which is the default, any, or none. So here, auto, it will decide if it needs to call some tools or not. Any, it will be forced to use some tools, and none, it will not use the tools. Parallel tool calls, it's also optional if you want that several tool calls can run in parallel, but here we want to process them one by one, so I set this one to false. And temperature, it's quite a good habit to use 0 when you are dealing with tool calls. So let's execute. And let's see what is the response. So we were used so far to do this, response, choices, the first choice at index 0, message content, to see what is the response from the LLM. But you will see that when it needs to run some tools, then the content is empty. And we got here an empty string. However, still within the message, you will receive now the tool calls. And you see that this is a list here, but there is so far only one tool call within this list. And within the tool call, you can see then this function argument, and then there is a function call. It contains the name of the function it wants to run and the arguments to provide to this function. So it wants to run adder, and x should be equal to 3 and y should be equal to 76, which is what we asked here in the prompt. So far it correctly identified what it needs to do. It identified the right function, plugged correctly the arguments, provided an ID to uniquely identify this tool call, and now this is up to us to execute the function and return the result to the LLM. And this is this workflow that we are going to do. So the first thing, we need to manage the memory. So we will append this message that contains the tool calls to the memory. And then we will loop through this list of tool calls. In our case, we've got only one tool call, but there could be several of them depending on your prompt. And you need to execute each of them. So we will need a loop to do this. And then at each iteration of the loop, we will need to extract the different parameters. So what is the function name, the arguments, and the tool call ID. After that, we can execute the function with the arguments that were provided, and based on the function name, we can identify the right function. And the result of this execution, we will save it in the new type of message that we haven't seen so far, which is called a tool message. So in this tool message, the content will be the output of the function, and we will also provide this tool call ID so the LLM can easily match this outcome with the original tool call. So it knows that this tool message is the response to the tool call it sent to us. And after that, we need to re-invoke the LLM after we've added all these messages to the memory. So the LLM will be able to review all the tool calls that it requested so far, the results, and it will be able to reason again about that. And then it will decide if it needs to run more tools. This will probably be the case in our in this situation, because we ask after to add up the two numbers to also multiply the result by 3. So it will realize that it still needs to call some tools. Or if it has all the facts already, it will then produce a response that you can find in the content as usual. So let's do that. I imported here tool message that we will need because we will create this to save the result of the function execution, and also the JSON library. So we will be able to access these arguments into a dictionary format and not as a string. So very first step, we said we need to append the response from the LLM to the memory, because so far what we've got in the memory, we can check. We are currently at this step. So there was the system prompt and there was my own request. So now we need to append the response from the LLM that had no content, but had some tool calls. And then, as we described, we need to run a tool. So for each tool call that we have in this, so response, dot choice, index 0, message, and not dot content this time, but dot tool calls. So we'll be able to step by step extract the arguments, execute the function, and append the outcome in the tool message. So here the name, we can find it in this tool call, dot function dot name. Let's have a look when we were a bit above. So we see that within the tool call, there is indeed this function key and then the name. The next one will be arguments that will be almost at the same location. So for arguments, tool calls dot function dot arguments, and you need to put them in this JSON.loads because you may notice here that we have this apostrophe before and after this dictionary, which means that actually the arguments are provided as a string and not like a Python dictionary. So we need then to convert it back to a dictionary that we can use in the function. And that's why we have these extra steps, JSON.loads for the arguments. And then we extract the ID, the tool call ID, to uniquely identify this tool call, and this is directly in toolcall.id. We don't need to go within the function in that case. Depending on the name that we extracted, we'll be able to identify the correct function that we need to execute. And we will see in another video that there is a better way of doing so, because you don't want a very large if statements if you've got a lot of tools. However, to get started, this is good enough when you've got just a few tools. So we are checking if the name of the function that it wants to run is adder, then we can run the adder function. Otherwise, if it is multiplier, we can run the multiplier function. In both cases, we save the result in an output variable. And you see that the arguments here, we use these asterisk arguments that explode the argument from the dictionary to the different parameters of the function. So then the result will be added in this variable output, and this is what we can now add to a tool message, which we append to the memory. So memory.append, we add a tool message, and as we said, the content, this is the result of the function, and usually it's a good practice to convert it to a string, because you may come across some errors if you provide some numbers. It depends on the SDK. Tool call ID, it's a mandatory argument, so it knows how to match it to the original tool call. So tool call ID here, this is in this variable ID that we created previously. And then the name here, apparently I made a mistake. This is not a string, but it should be this one. So it's optional, but for extra context, you can also provide the name of the function that was executed. and for which you provide now the result in tool messages. So let's run it. And let's check again how does the memory look like now. So we can find the system message that we had at the very beginning, just explaining what is the task. Then there is my request asking to add up these two numbers and to multiply them by 3. Then we added this assistant message that had no content, but it had some tool calls. And finally, after we executed this function, we added a tool message to the memory with the result of this calculation. So 76 plus 3 is, of course, 79. And you can see that here the tool call ID that was added to this tool message is exactly the same that you can find here. This is how the LLM will be able to match the assistant message and the tool message. Actually, I had already a loop here where we can display, but this is exactly the same outcome, it's just a different formatting. And we said that after we've done all of this, we need to re-invoke the LLM. So we request a new completion. So here, the same as before, and I provide my tools again. I still say that you need to use some tools. Actually, let's do it automatic. Like this, the LLM can decide if it wants to run additional tools or not. And we can, execute it and directly add the result in the memory. And once again, let's check if we've got some tool calls. And as expected, there is still a tool call, but this time for the second function, multiplier. So you see that here, the first argument, they provided the result of the previous function, 79, and then the y parameter is 3, so it wants to multiply 79 by 3. It provided a new ID to identify this tool call, and we need to go exactly through the same process as before. So here I just copied and pasted the exact same code, and then I will display the updated memory so we can see where we are in the process. So again, system prompt, the first question I asked, then the first tool call that was produced by the LLM, the result, the second tool call that the LLM wanted to run, 79 multiplied by 3, and here we provided the result after executing our function. So now we will re-invoke the LLM, and we'll put auto, because it's very likely in that case that it does not need to run additional tools because now it has the answer to our question. And this time I will directly display in Markdown the content of the message because I expect that now the LLM can produce a response, and therefore I want to display it to the user. And I just forgot to import this Markdown module, so from IPython with a capital P dot display import Markdown. And we can see that based on the entire conversation, based on the entire memory list, the LLM now is able to produce an answer to our question. So the result of 3 plus 76 is 79. And then if you multiply it by 3, it gives 237. And I will stop the video now so we don't make it too long. But in the next one, we will see how we can improve this process, because obviously we don't want to just keep copying and pasting our code each time there is a new tool call. We want to operate everything in a loop, and the LLM just stops as soon as there are no tool calls anymore. And I will also show you how you can improve that part so you can dynamically retrieve the correct function. So I hope to see you in the next video, and I wish you some good practice with that. Bye bye.